graph trigonometric functions. So we're going to start off with the function y equals 9 minus 6 cosecant parentheses 1 over 8x minus pi. In order to make that an easier function to graph, we're going to go ahead and change the cosecant with sine. And then we're going to go ahead and find our amplitude. Our amplitude is negative 6, but we're going to get the absolute value, which is 6. And then our d, as shown up here, is 9, and this just tells us how up or down it's going to go. Now we're going to find our period, which period we figured out by doing 2 pi over b. In this case, we have 2 pi over 1/8 because it's what our b is up here, which is in front of the x, and so then we have 1/8 at the bottom. In order to cancel that out, we multiply by the reciprocal and we get 16 pi. And then we're going to find its interval. Its interval is period over 4, which in this case is 16 pi over 4, giving us 4 pi as our interval. Then we're going to find out phase shift. Our phase shift, we're going to set whatever's in our parentheses up here, 1/8 over x minus pi. Down here, we're going to set it to 0, and then we're going to set it to 2 pi, like here. And then right here, we're going to go ahead and add pi to the other side. And then we're going to go ahead and do 1/8x equals pi. In order to get rid of that fraction, we're going to multiply by the reciprocal, and then multiply the other side, giving us x equals 8 pi. Like the other side, we're going to go ahead and do the same thing. We're going to add pi to both sides. And then we're going to, in order to cancel out the fraction, we're going to multiply by the reciprocal, multiply the reciprocal with a 3 pi, giving us x equals 24 pi as our ending point. Then we're going to go ahead and do a chart with our x and y. We're going to go ahead and do our chart starting off with 8 pi. 8 pi is our starting point. And then we're going to go ahead and add our interval each time as we go down the chart. And our interval in this case was 4 pi. So then we would do 8 plus pi over 4 pi, and it would go 12 pi, and keep on doing it throughout the chart. Then we're going to figure out our y, which our y is d equals 9, and then d plus a, which our a in this case is negative 6. So we'll do 9 plus negative 6, giving us 3. And then our d is 9. Our d minus a would be 9 minus negative 6, giving us 15. Then our d, in this case, is 9. Then we're going to go ahead and graph. Our graph in this case is, we're going to go ahead and set our intervals. With our intervals is 4 pi, 8 pi, 12 pi, 16 pi, 20 pi, and 24. Then we're going to go ahead, and our points that we had in the chart, we're going to go ahead and graph them, each on here. See how these 3 points line up on the x-axis? We're going to go ahead and do that as our asymptotes. And then this would go down, this would go up, and then if you want to continue, since this one's down, this one would go up. And then our domain in this case is 8 pi to 16 pi, 16 pi to 24, 24 pi to 32 pi. Our range is from negative infinity to 3, and then 15 to 8 pi. Our asymptote is x equals 9 times its period. But since it's an asymptote and we have 2 curves in a period, we're going to go ahead and divide by half. So that gives us 8 pi. Our period is 16 pi. Our relative maximum point is 12 pi, because right here, this is our maximum, is 12 pi. It's at the 3, so it's going to be 12 pi plus n times this period, 3. And the relative min, as looked up here, we have it under the 20 pi. So look at it under 15. So we're going to do 12 pi plus n times this period, which is 16 pi, and 15. So this concludes the function. This concludes the lesson for y equals 9 minus 6 cosecant 1/8x minus pi.